Hi, it's day 7. Wanted to talk about arrays. So we're looking at the 30-day Hacker Rank Challenge for beginners to intermediate to more advanced problems. And then we'll be transitioning to leak code and we'll be transitioning to more advanced algorithms going further in this video series. So I just wanted to go over the problem set, go over two solutions, both Python and C++, and leave you with a few questions. So let's get started. First, we're given an array, and we have to reverse the order of the elements in the array. Well, in Python, this is actually extremely easy. You don't even need to know what elements there are within the array. And so, in this case, we're given a template, and the template is checking to see if we're in the main function, which we are, or if this is the main source code, main document, which it is. It inputs uh, inputs the length of the array. In Python, we're not concerned with how long the array is or what type of elements are in there. As you'll see later, it's data type agnostic, which just means that you're able to perform a reverse sort or a reverse of the elements rather easy without having to know what's under the hood. And so in this scenario, it takes the input for the first value, which is going to be the amount of elements in the array, and it wraps it, after cutting off the white spaces, wraps it in int function, which converts it to an integer, stores it in variable n. The next line takes the array and does most of the work. And what it does is it inputs 1, 4, 3, 2, and then it strips the white space on the side and on the right side, and it splits between 1, 4, 3, 2 in order to pass it to the list function. So essentially, this whole line takes the input 1, 4, 3, 2 and makes a list so that slot index 0 is going to be 1, slot index 2 will be so slot index indexed at 1, which is the second element, is going to be 4. Slot index that is indexed at 2, which is really the third element, is going to be 3. And the last index, so it's going to be indexed at 0, 1, 2, 3, and it's going to be 2. So what it does from there is you can join them all together with a space, use the join function, and reverse the elements in the list. In this case, all you have to do is do a blank start, blank stop, which just means from start to finish, and with a -1 stride, which means you take all the elements, but you reverse them in the list. And that's all we have to do for Python. C++ is a little more complicated. We've gone through a lot of these different auxiliary functions, like ltrim, rtrim. We haven't looked at split yet, and so as you may guess, split is going to work with the spaces in between each of the elements. And so let's see what it does. So it takes a parameter that's constant. It takes the parameter of string data type and stores it by reference within str, the str variable. Before going into the rest of the function, we need to realize that it does return a vector of data type string. What this means is essentially it's holding an array or a list of all string data types. So what's interesting here is it stores, or I guess it declares a vector of data type string called tokens, and you're given the size type, string size type of 0 and end of 0. And what it does is the string has a method called find, and we're finding the white space. And so we're going to start at 0, and once we find a white space, we're going to store it in n, and we're going to use a while loop to continue doing this until we find the end of the string, which is going to be that no position or end position. And so if it doesn't equal string no position, or the end of the string, then you continue going through. And what we're going to do is we're going to push back, which is a method associated with vectors. What this means is you essentially append it to the end. And what are we appending? Well, we're appending the string with that calls a method substring. So not the whole string, but part of the string from the start to the end minus start. So essentially you can consider that that method is going to push back 1, it's going to push back 4, it's going to push back 3, it's going to push back 2. Going further along that method, you want to then start one past that position that you just stored at end. And that's going to continue until you go over the entire string and find all the spaces so that you can include all the elements of data type string within your vector container. And so we've found what we're looking for, and we push back the last element to make sure that we include all data elements, because at this point we found the end of the string and we know that we're still working from start that is one past the previous end, which means that at that point in the method we are looking at 2. So 2 is going to be stored finally within your vector container of data type string. And then, as mentioned earlier, you're going to want to return that container that's of data type string, and it's going to be used in the main function. So watch previous videos for the left trim and the right trim discussions. We just covered the split function. And so now let's go through main. It is important to note here that you're using namespace std, which means that essentially you're within the standard library and your scope resolutions in the standard library. So you don't have to use std in front of all the different functions or data type declarations that you would normally do if you didn't include the namespace resolution or namespace mapping, whatever you want to call it. In this case, we define an ntemp variable of string data type. Then we use the sin, which is the standard input that's passed in as a first parameter to the getLine function that then stores that information towards ntemp, which is going to be the number of elements. So 4 gets stored in ntemp. We left strip and right strip or trim on the ntemp. We convert the string to an integer and we store it in int n, or the variable n of data type integer. Now we know how many elements are in the standard input, and we can use that information to then store it within our container. In this case, the container is going to be a vector, and that vector is going to be of data type string. So let's define our next variable, which is going to be the array temp. Probably should use different names. I guess you could just use array here, but array temp is going to be of data type string. Once again, we're going to use the getLine function with the first parameter being standard input, and we're going to store all the elements associated with the second line within array temp temp. We have to split after we are trim. So we're going to want to take all the space out on the right side, but we want to leave these spaces so that we can pass it to our tokenizer. Essentially, that's going to be your split function. And so you trim all the white space on the right associated with array temp temp, and then you pass it to the split function, which we discussed earlier. After that, the return type is going to be of vector string, and that's going to be your container that's associated with the data type strings, or data type string. All the elements are going to be of string type. And so now you have your array temp. And this is why they named it array temp temp, and then array temp, and then array. It's a little tacky. They can improve their naming conventions, but let's go through the next step of the program. So now we have a vector of data type integer, or int, and this is going to be the array variable that's declared with an initial volume or size of n. And n was declared earlier. Remember, it's going to be 4 in this situation. So this vector of data type int is going to allow the variable array to store 4 different integers. And so now we're going to go through what we have tokenized or split up in array temp. And so we're going to go through a simple for loop all the way up to variable n, which means we're going to cover all elements. And we're going to look at the first value that we parsed, and the second value, and the third value, and the fourth value. We're going to take each of those during the iteration, its given iteration, and convert that string into an integer and store it as an array item. And then we can assign that array item to that particular, to its index within its array. And what's interesting here is they did a couple extra steps where if you just replace array item with array I up here, then you can make it shorter. But I think it's just to make it more transparent. And so now we're finally getting to the result. However, we need to start at the last index and go to the first index. And so what happens here is you take the method size and you subtract 1 so that you're indexing at the last point. Remember, C++ does zero-based indexing. So essentially array.size would be 1 too far, which would be a buffer overflow. Instead, we want to go 1 less than the endpoint. And we go all the way to -1 so that we make sure we include the first index, which is going to be index 0. And you subtract each iteration by 1. So size goes down by 1 each time. And you just output the result and make sure you follow the correct formats associated with the judging system, and then return 0. And that's going to be day 7, or really the 8th challenge of the 30-day challenge. Once again, I appreciate your time and your help. I hope you continue watching these, and I can't wait to see you on future videos. Have a great day. Bye.